Picture this. You're an astronomer, having your morning coffee, scrolling through the night's telescope data, probably wondering if you'll spot anything more exciting than another routine asteroid. Then bam! Your computer screen lights up with something that makes you spit out your coffee and question everything you learned in graduate school. This incident occurred in spring 2020, when astronomers discovered 3I Atlas, a cosmic visitor that treated the laws of physics as mere suggestions. The uninvited guest that rewrote the textbooks. When automated survey telescopes first caught sight of this mysterious streak of light dancing across the star field, scientists initially yawned. Oh great, another comet, they probably thought. Add it to the pile of icy snowballs we've catalogued. But within hours, and I mean hours, NASA was frantically issuing emergency classifications and updates. Why the rush? Because 3I Atlas wasn't just any ordinary cosmic debris. It was the third confirmed visitor from interstellar space, carrying a passport stamped from places our solar system has never been. Think about the astronomical odds here. Out of all the possible directions this thing could have come from across our entire galaxy, it decided to cruise right through our cosmic neighborhood like it was following GPS directions. At 59 kilometers per second, that's roughly 130,000 miles per hour for those keeping score. This wasn't some leisurely Sunday drive through space. 3I Atlas was moving so fast that our sun's gravity couldn't even think about capturing it. This comet was a one-way ticket, a cosmic hit-and-run that would never return. Unlike our familiar comets with their predictable elliptical orbits, this visitor traced a hyperbolic path through space like it had somewhere crucial to be. When comets start breaking their own rules. Now, here's where things get deliciously weird. Every astronomy textbook will tell you that comet tails always point away from the sun. It's as basic as gravity making things fall down. Solar radiation and stellar winds blast comet material outward like a cosmic leaf blower. This principle has been true for literally every comet we've ever observed in the history of human astronomy. But 3I Atlas looked at this universal rule and said, "Hold my space beer." Its tail was pointing toward the sun. Let that sink in for a moment. Imagine walking outside during a hurricane and seeing someone's hair blowing toward the wind instead of away from it. That's the level of, wait what, we're dealing with here. Astronomers stared at their instruments, probably tapping the screens and wondering if they needed to call tech support. But the data kept coming back the same. This thing was shooting material sunward, like it was trying to give our star a cosmic high five. Such behavior wasn't just unusual, it was physically impossible, according to everything we understood about how space works. Unless, of course, something inside 3I Atlas was deliberately controlling the flow, something that knew exactly what it was doing. The chemical cocktail that stumped scientists, spectrometers, delivered a shocking revelation that left astronomers stunned. Most comets are basically dirty snowballs, lots of water ice with some carbon compounds thrown in for flavor. It's a recipe that's been consistent across every comet we've studied, like the universe's most boring cookbook. 3I Atlas decided to completely rewrite that recipe. Its chemical signature showed an 8:1 ratio of carbon dioxide to water. For perspective, that's like ordering a pizza and getting 8 pounds of pepperoni for every ounce of cheese. No other comet in our solar system or any confirmed interstellar visitor had ever displayed such proportions. But wait, there's more. And yes, I feel like a cosmic infomercial host right now. The spectrometers also detected atomic nickel. Now, If you paid attention in chemistry class, you'll remember that metals like nickel don't just float around as free atoms at the temperatures we're referring to. Nickel should be locked away in minerals, buried deep in planetary cores, or trapped in meteorites. Finding it sublimating off a comet's surface is like finding a penguin sunbathing in the Sahara. Technically possible, but requiring some very special circumstances. Some scientists tried to rationalize the phenomenon by suggesting 3I Atlas formed in some incredibly exotic stellar nursery where such chemistry was normal. Others weren't buying it. When you see a penguin in the desert, the simplest explanation is that someone put it there. The trajectory that defied coincidence. If the chemistry wasn't strange enough, 3I Atlas's flight path added another layer of cosmic weirdness that would make conspiracy theorists rub their hands together gleefully. Most interstellar objects should arrive from completely random angles across the galaxy. Space is big, really, really big, and the odds of something naturally aligning with our solar system's orbital plane are astronomically small. Pun absolutely intended. However, Atlas 3I approached Earth's solar system along a trajectory that was suspiciously well aligned. The statistical probability of this happening by pure chance was roughly equivalent to winning the cosmic lottery while being struck by lightning during a solar eclipse. It was almost as if something had plotted a course specifically designed to intersect with our neighborhood. Which raises an uncomfortable question. If you were an advanced civilization wanting to send a probe to study a particular star system, wouldn't you naturally align your approach with the target system's orbital plane for the best observational angles? The pattern that made everyone nervous to truly appreciate why 3I Atlas sent shivers down astronomers' spines, we need to zoom out and look at the bigger picture. This was not humanity's first encounter with mysterious interstellar visitors. The story begins in October 2017 with Oumuamua, a name meaning messenger from afar, arriving first. How's that for ominous foreshadowing? This cigar-shaped oddball became the first confirmed interstellar object ever detected, and it immediately started breaking rules. Oumuamua was elongated beyond anything in our cosmic experience, tumbling through space like a cosmic cigarette. But here's the kicker. After swinging around the sun, it accelerated. Instead of slowing down as gravity predicted, it accelerated. Scientists scrambled for explanations, suggesting invisible outgassing, but no jets, no tail, and no visible evidence were ever found. Harvard astronomer Avi Loeb boldly suggested what others whispered. Maybe it was an alien light sail. Despite the academic community's cautious approach, the math revealed a troubling consistency with artificial propulsion. 2 years later, in 2019, amateur astronomer Gennady Borisov spotted another interstellar visitor. This one looked more traditionally comet-like, with a proper tail and coma, but its chemistry told a different story. Borisov was loaded with exotic ices and carbon monoxide levels that screamed, "I'm not from around here." So let's recap this cosmic timeline. 2017 brings us a mysterious accelerating shard. 2019 delivers a chemically alien but otherwise normal-looking comet. And 2020 presents 3I Atlas with its backwards tail and controlled-looking propulsion. 3 visitors in 3 years, each progressively more unusual, raised more questions than answers. For centuries, humans scanned the skies without spotting a single interstellar object. Then, suddenly, like cosmic buses, 3 show up at once, each breaking different laws of physics in ways that almost seem methodical. When propulsion looks like propulsion, as scientists continued studying 3I Atlas's bizarre behavior, an uncomfortable comparison kept surfacing, one that most researchers preferred to discuss in hushed conference room whispers rather than peer-reviewed papers. The object's plume wasn't chaotic, like natural comet outgassing. It was directed, controlled, and persistent, remarkably similar to advanced propulsion systems humans have developed, just scaled up to interstellar proportions. Consider our ion engines, elegant spacecraft propulsion that ejects charged particles at incredible velocities to create thrust. These engines emit a faint, steady signature from a distance that one could easily mistake for natural phenomena. Now imagine a civilization that perfected this technology not decades ago, but millions of years ago. 3I Atlas's sun-facing plume raised another intriguing possibility: solar thermal propulsion. Advanced spacecraft might use a star's intense radiation to heat propellant and generate thrust, essentially turning our sun into a cosmic gas station. The steady direction of the plume, along with noticeable changes in the spacecraft's orbit that matched the jet's angle, suggested that it was flying in a controlled way instead of just ice melting randomly. The numbers don't lie, even when we wish they would. In science, speculation is cheap, but mathematics is expensive and unforgiving. When astronomers calculated 3I Atlas's precise orbital mechanics, the numbers revealed something that made everyone uncomfortable. The object wasn't following the path that pure gravitational physics predicted. A non-gravitational force perfectly matched the direction of its mysterious sun-facing plume, nudging it off course. Computer simulations tried desperately to reproduce the trajectory using conventional comet physics, random outgassing in multiple directions. The models failed spectacularly. It was only when scientists assumed a single, directed emission that the math worked. For comparison, traditional outgassing models fit 2I Borisov perfectly. They explain countless solar system comets flawlessly. However, when confronted with the 3I Atlas, conventional physics was unable to provide any explanation. The orbital deviation was detected during a critical window as the object approached the Sun, timing that suggested calculated course corrections rather than random venting. If this was natural outgassing, it had remarkably convenient timing and direction. The perfect heist, vanishing behind the Sun. As October 2020 drew near, astronomers came to a startling realization. 3I Atlas was heading for a solar conjunction, a perfect alignment that would hide it behind the Sun from Earth's perspective. For weeks, the object would be completely invisible to every telescope on our planet. Talk about convenient timing for something that had already displayed suspicious behavior. Think about it. If you were operating a disguised probe and needed to perform sensitive maneuvers without detection, could you ask for better cover than hiding behind a nuclear furnace? No human instrument could possibly observe what happened during that cosmic blackout. On October 30th, 2020, 3I Atlas slipped behind our Sun and vanished into the glare. For weeks, humanity could only wait and wonder. Was it simply burning away like any fragile comet caught too close to our star? Or was something else happening in that hidden theater of operations? When 3I Atlas finally re-emerged, it appeared fractured and dimmed, apparently broken apart by solar stress. Mainstream science breathed a sigh of relief and filed it under mystery solved, comet destroyed by Sun. But skeptics asked a more unsettling question. What if the breakup was intentional? What if 3I Atlas had shed its disguise, leaving behind something smaller and harder to detect, while the outer shell drifted away as cosmic camouflage. Imagine a scenario where you approach as an obvious comet, carry out your real mission behind the sun's glare, and then leave a trail of debris as evidence of your destruction, while your actual payload continues undetected deeper into the solar system. The unsettling conclusion. Atlas leaves us with more questions than a philosophy exam and twice as much existential dread. Its backwards tail, exotic chemistry, controlled propulsion, perfect timing, and convenient disappearance behind the sun create a pattern that's either the most remarkable series of coincidences in astronomical history or evidence of intelligence operating in our cosmic backyard. The truly unsettling part isn't just that 3I Atlas was weird, it's that it was weird in all the right ways to accomplish exactly what an advanced probe might need to do: approach undetected, gather data, execute maneuvers undercover, and vanish without a trace. Whether 3I Atlas was nature's most elaborate practical joke or technology beyond our understanding, one thing is certain. It forced us to confront the possibility that we're not alone, and that intelligence might be far more subtle and sophisticated than we ever imagined. So the next time you look up at the night sky, remember that somewhere out there, cosmic visitors might be watching back, hiding in plain sight among the stars, following rules we haven't learned yet, and playing games we don't even know we're part of. After all, if 3I Atlas taught us anything, it's that the universe still has plenty of tricks up its sleeves, and some of them might just be looking back at us, wondering if we're smart enough to notice. The question isn't whether we're alone in the universe anymore. The question is, how long have we not been alone, and what has been watching us?